Okay, folks, this video segment is for creating and modeling a wheel, an axle system which rolls on a track. Okay, this is shown here, so let me go ahead and do that. Let's first insert the track, insert a new part in there. And let's call this thing the track properties, change it to track and track. Track and track. And let's make it. Double click on a convenient plane on say this vertical plane. I will sketch a rectangle and then pad it. There we are. Exit and pad it. So this will be our track. Let's make it 3 inches. Right, good. Then we're going to insert the chassis of the car. So insert, new part. Let's call it the frame. Okay, how about that? Properties, frame, and frame. Okay. Let's make it on a convenient plane. On this vertical plane, I will sketch another rectangle like that. Okay, and let's make a circle here. This is where the axle is going to get inserted. Okay, and another one right there. Let me see for a second. All right, and exit and pad it. Okay, so that's going to be the, let's call it the frame. Then we're going to need 2 axles. Actually, these axles are identical, so all I need is to make one of them, and then after I save, I can use an existing component. So insert a new part, and let's call it axle. Properties, axle, and axle. Okay. Before I do that, let me find out what the length of the pad was here. So let's make this thing 1 so that I have a better idea of what these sizes are. Now we go and make the axle. So this is, yeah. So on a convenient plane, for example, on this plane, I will sketch. Why don't I project that circle? There we are. Okay. And let's look at the front view. So let's make a wheel here. Another circle, concentric with that. This is going to be the wheel. Exit. Why don't we do a, how about a multi-pad here? So multi-pad. The sketch. So this is going to be the big circle. Let's make that thing point 2. Okay, and the other one, the smaller circle, let's make it 1.2. 1.2. Preview. Okay, that's good. Exit. Now let's complete on this side. So on this face, I will sketch a circle, but I'm going to project that. Okay, so project this. Okay, and then exit and pad it by 0.2. Basically make something like that. Alright, just to see that this guy is rolling, I'm going to make a feature here. On this plane I will sketch a little circle. This is going to put an indentation in my wheel so that I can see actually that it is rolling. Let's make a tiny pocket here. How about 0.05, just so that we have a feature there and we can see it. Good. Now, one thing I wanted to tell you, first of all, let's go ahead and save this thing. File, save management, save as, new desktop, new folder, wheel, rolling, on track, and we're going to put our product and all these parts there. Okay, let me now notice that the resolution of the Catia screen is so that this is not quite a circular. It's kind of like a broken line. To fix that, or even if you look at this this hole here, it's not as smooth as we want. So to fix things like this, you go Tools, Options, and under Display, under Performance, and with playing with these sliding bars, you can actually make it look better. For example, if you ask for proportional here and drag it, actually that didn't help, so let's try the other one. Tools, Options, let's try proportion on this one, 3D accuracy maybe. Yeah, that's better. Still didn't help. Tools, Options, let's see, level of details, 3D accuracy, let's drag this thing all the way to the end. I would say that that's what it is. So actually this got worse, as you can see. Tools, Options, let's see. I pull this thing all the way to the end. Ah, there. Okay, went in the wrong direction. All right, good. Let's move on. Now we're going to insert another copy of this, because now that we have saved it, so we can say insert existing component. Oh, wait a minute, where are we? Product, insert existing component in there, and what we want is the axle. So this is not the correct folder, so we go to the correct folder, which was called wheel rolling on a track, right there, and axle. Okay, so it is there, except that they're sitting on top of each other, and all I need to do is to translate this in the direction Y, and you see there are two of them. Okay, now comes the assembly process. So first thing we're going to anchor the track. Okay, good. Then we're going to create a well, let's see, a constraint between the axis of this axle and the axis of that hole. So coincidence, the axis of the axle and the axis of the hole. Of course, there's nothing update because it was already there. And also coincidence in the back face of the wheel and the front face of the axle of the frame, and update. There we are. And do exactly the same thing with the other one. So coincidence between this axis and that axis, and coincidence between this face and that face. and update. Okay, good. Now we're going to bring this thing down and put it on that track. Now ordinarily, well, first of all, let's make this whole thing closer to the track. So check this box and then translate in the Z direction. There. Now let's see if contact will work. So if I say contact between this face and that face, see, this one works, but oh, there we are, and that face. And if the internal does not work, try external. Let's try update. Nope, this doesn't work. So change it to external. So double click on that. More, and go from internal to external, and OK, and update. Right there, you see, they're sitting on top of each other. This is now sitting on top of that. Now let's push this thing so that wheel becomes flush with that surface. So coincidence between this face and this face, and update. There we are. Okay, very good. All right, so we now go to the, let's save everything. We now go to the digital mockup, EMU kinematic, get the magic wand out, new mechanism, auto create. What we're going to see is probably a planar between these two, because I've made this plane and that plane coincident. That gives you a planar joint and two revolute joints. So let's check it. Yeah, planar and two revolute joints. So what we need to do is this wheel to roll on that line, not slide, but roll. So let's go and find the roll curve between this wheel and that line, or this perimeter of that circle and this line, and you say OK. All right. Now, what have we got? Degree of freedom is 3, and let's do it with this guy. Roll curve between this fellow and that line. Now the degree of freedom is 1, and we can make one of these revolutes angle driven. So or one of those roll curves length driven. So let's go from 0 to 360. Of course, mechanism can be simulated, and we can create a cartoon. Let's do it, mechanism. Okay, so there we are. Insert, rewind, and you can play it continuously. Let's make this thing so that it goes forward and backward. Make it faster. Okay, notice that these are rolling, they are not sliding. So that takes care of this particular exercise. Now we have done 2 roll curve problems. One of them is this, the other one is something that I already posted, which is a wheel rolling on a cam. You should look at all of these, because they will pop up later in the final exam. Now keep in mind that when you create point curve, slide curve, roll curve, and point surface, these must be already, the point must already be on those, or the curves must already be touching each other, whether it's a roll curve or slide curve. All right.